Hello everyone and welcome back. So in our last lecture we learned what is line integral and its applications. So in today's lecture we will learn what is surface integral and we'll also do some application on surface integral. Now if we integrate a function over a curve, then it is called line integral, but if we integrate a function over a surface, then it will become surface integral. Okay, that will become surface integral. Now let us consider a surface S. So if we draw a surface S, suppose this is one surface S. Okay, the name of the surface is S, and then capital F bar be a vector valued function which is defined at each point on the surface. So if we take any point on the surface, at each point the vector valued function is how much? F bar. After that, let us take a point P, and if we draw one outward drawn normal on the surface S at the point P, and let it be denoted by what? N bar, or you can write n cap also. Now because we know that at each point each point on the surface the vector valued function is how much? F bar. So any force has two components, right? One is along tangential direction, another one is along normal direction. Now if we want to find the normal component of F bar, then that is nothing but F bar dot N bar. So F bar dot N bar is what? Along normal direction, because we are like if we write x I cap means what? X is the component along x axis because I cap is there. So similarly, since it is with N bar, so it means this is the component of the vector valued function along what? Unit outward drawn normal. Now if we integrate this particular normal component of F bar, then it will be denoted like this: double integration over S. Since it is surface, so there will be two variables, that's why double integration F bar dot N bar ds, and this particular integral is called what? Surface integral. Now how will integrate this? How will integrate this surface integral? That will try to understand now. Now see, if we take this x-axis, y-axis and z-axis. Now since this is a surface, no, the projection, so the projection of this surface will be like this, something like that. So this is the projection of the surface S. So it's on two dimension, xy plane. So it's a plane, simple plane. Though surface is three dimensional, but if we take the projection, means shadow of this particular surface, then we will get a region. That particular region is what? R. Here it is written like R1. Let R1 be the projection of S, means this surface on the xy plane. Okay, and k bar is the unit vector perpendicular, means we are talking about k cap. K cap is along z axis, or we can say the normal to this xy plane. Then ds can be expressed like this: ds equals to how much? Dx into dy divided by modulus what? N bar dot k cap. Okay, so since it is xy plane, so dx dy. If you take suppose yz plane, then it will be dy dz. If we take xz plane, then that will be dx dz. So if we put this particular value here in the integration, then double integration over s f bar dot n bar ds equals to how much? Now it is double integration over r1. Okay, since we are concentrating on the projection, r1 f bar dot n cap, and in place of ds, now what you can write? Dx dy divided by modulus n cap dot k bar, n bar dot k bar. But if we take the projection on yz plane, then this dx dy will be replaced by dx, on yz plane, no? So if it is yz plane, then this will be dy dz. Okay, divided by what? Modulus n bar dot k cap, n bar dot I cap. And then if we take the projection on xz plane, then this will be dx dz divided by modulus n bar dot what? J cap. So we will try to use this particular result always on the xy plane. And examples are also very simple. The examples are a little bit lengthy, but it's very simple. Okay, so we have to take this particular formula. Okay, now let us go to our first problem. Now see what to do. Evaluate double integration over S. Okay, double integration over s f bar dot n cap ds. If f bar is given and s is the surface of the plane, the surface of the plane is also given. It is twice x plus y plus 6z equals to what? Twice z equals to how much? 6. And we have to evaluate the surface integral on the first octane. So if we divide a two-dimensional figure, then we will get 4 quadrant. But when we divide a three-dimensional space, then we will get 8 quadrant. First octane, 8 octane, first octane, second octane. So here we have to take first octane. First octane means x, y, z all will be positive. Okay, now let's do the solution. Here f bar is how much? Our f bar is x plus y square I cap minus twice x j cap and then 2yz k cap. Okay, and then there is one plane, surface of the plane, that will denote like this. Let phi equals to twice x plus y plus twice z minus how much? 6. Now we'll find gradient of phi, nabla phi. So gradient phi means what? I cap what? Del phi by del x. So if we differentiate this with respect to x, what we will get? You will get 2, right? Then plus j cap del phi by del y. So we will get only 1, and then k cap del phi by del z. So if we differentiate with respect to z, again what we will get? 2. So we have 2 I cap plus j cap plus 2 k cap, right? So what is unit normal? Unit normal. So in gradient we already learned this. The unit normal is, formula is what? Gradient of phi divided by modulus of gradient phi. So it's 2 I cap plus j cap plus 2 k cap divided by magnitude of this. So magnitude of this is how much? Root of r 2 square plus 1 square plus how much? 2 square. So it is 2 I cap plus j cap plus 2 k cap divided by how much? 3. Okay, so this is our n cap, means unit normal vector. After that we have to find f bar dot n cap. F bar dot n cap. So f bar is given. This is our f bar. Okay, this is our f bar and this is our n cap. So we'll take the dot product. So if you find the dot product, what we'll get? I cap dot I cap. So here with I cap, what you have? 2 by 3, or you can take 1 by 3 common also. 1 by 3 common. So we have to take dot product of this and with what? 2. So it will be how much? 2 I, okay. So we'll get 2 into means twice x plus 2y square. Okay. Then here with jk we have minus twice x. Here with jk we have 1. So ultimately we have minus twice x. And then finally what we have? We have 2yz. Here we have 2yz and here we have 2. So it will be 4yz. So this is our f bar dot what? N cap. Now see, since this surface, so in and we will take the projection of the surface on xy plane. So on xy plane z is not there. So we have to replace z. From where we will replace z? So what is the given surface? Twice x plus y plus twice z equals to how much? 6, right? This is given. So from here our twice z will be equals to 6 minus twice x minus y. So in place of twice y, we will replace this value. So this is equals to half into twice x cancel out. So you will get 2y square. Okay, 2y square plus twice z into twice y. So you can take, so it's 3. So you can take 2 common also, 2 by 3. Then inside we have y square plus twice z. In place of twice z, what will write? 6 minus twice x minus y. Okay, and from twice y we have taken 2 common, so we have only y. So now if we multiply all the term, what we will get? 2 by 3 it's y square plus 6y minus 2xy minus 2xy and then minus y square. Okay, so y square cancel out. This y square will be cancel out. So what we have, we can take 2 common, 4 by 3, and then how much? 3y minus what? xy, since we have taken 2 common, right? So this is the value of f bar dot n cap. Now let r be the, you remember in definition we wrote like this, let if r be the projection of surface S on which plane? On xy plane. So what will be the formula then? Then ds we can write like this, then ds equals to dx into dy divided by modulus n cap dot k cap. Okay, so n cap is what? This is our n cap. So this is our n cap, right? 2 by 3 I cap, 1 by 3 j cap, again 2 by 3 k cap. So this is our n cap. So with this vector we have to take the dot product of k cap. So k cap dot k cap is 1. So what we'll get? We'll get only 2 by 3. So it will be dx dy divided by how much? 2 by 3. So means 3 by 2 dx dy. Now we can easily find the surface integral, which is double integration over S f bar dot n cap then ds. Now what is the projection of the surface S? Is r. So now we can write double integration over r f bar dot n cap. So f bar dot n cap is how much? It is 4 by 3 then 3y minus xy. So you can take y common, so it will become 3 minus x. Okay, now in place of ds, what we can write? We can write 3 by 2 dx dy. Okay, so 3 will be cancel out, 2 and 4 will cancel out, so we can write 2 into double integration over r 3 minus x y dx dy. Now the most important part comes about the limit. Now you see we have two variable x and y, so you have to put the limit. Okay, otherwise you can't do the integration. So how will put the limit, that you have to understand. So what is the surface? Our surface is twice x plus y plus 2z equals to how much? 6. Now see, r means what? xy plane. So on xy plane z will become 0. So there will be no z. So we have only twice x plus y equal to 0. Sorry, twice y plus y equals to 6. Now first we will find the limit of y. So y will be equals to how much? 6 minus twice x. It is given in the question that, so we have to write like this, integration, then again integration. So y will be equals to 0. Why 0? Because it is given that we have to integrate, or we have to find the surface integral on first octane. So first octane means all positive. So it will start from 0 to what? What is the value of y? It is 6 minus twice x. Then what will be the limit of x? X will start from 0 due to first octane to how much it will go. Now when we will come to x-axis, on x-axis the value of y is again 0. So you have 6 equals to twice x, means what? X equals to how much? 3. So x equal to 3. So just remember this thing. So when we find the limit of y, we have to put z equal to 0. Again, when we have to find the limit of x, we have to put y equals to 0. Then we have 3 minus x dy, then dx dy. Now we'll integrate it. Now it's a very simple integration. Okay, so you see the limit of y is depending on what? X. Since the limit of y is dependent on x, so first we have to integrate with respect to what? With respect to y. So x equals to 0 to 3. So 3 minus x you can keep outside. Now which one we have to integrate? We have to integrate y. Okay, so integration of y is y square by 2. what is the limit? Limit is 0 to 6 minus twice x dx. So we already integrate with respect to what? Y. So here 2 cancel out. So 0 to 3, 3 minus x. Now if you put the limit, what will get? You will get 6 minus twice x whole square dx. Now from here we can take 2 common. So if we take 2 common, since square is there, so it will become 4, 0 to 3. So 3 minus x is already there. And if we take 2 common, another 3 minus x whole square will be there. So it will be 3 minus x whole cube dx. Now it's a very simple integration. If you integrate it, what we will get? You will get minus 3 minus x whole to the power 4 divided by how much? Now it is minus 4. Why minus 4? Because one minus is there, no? So if we differentiate it, one minus will be there between the limit 0 to 3. Okay, so minus minus it will become plus, right? Minus minus plus, and you can cancel 4. Now if you put the limit, when we put 3 minus 3, it will become how much? 0. Sorry, this minus will not be there. Okay, so my 1 minus will be outside. So if you cancel 4 and 4, 1 minus will be outside. Now if you put the upper limit 3, it will become 0. Then minus, if you put 0, it will be 3 to the power 4. 3 to the power 4 is how much? 81. So minus minus plus 81 units is the answer. Okay, so the calculation is a little bit lengthy, but it's very simple. Okay, now let us take one more problem. We have to show that double integration over s, f bar is given, n cap we have to find, is equals to how much? 3 by 8. Now what is important? Surface. So here phi is how much? Phi is x square plus y square plus z square minus 1. So first what we have to find? Gradient of phi. Gradient phi is how much? I cap del phi by del x. So if you differentiate, you will get twice x. J cap del phi by del y. So means twice y, and then k cap into what? Twice z. Right? That you have to find. And then what is the definition of the unit vector? Unit normal vector. Unit normal vector. It is denoted by n cap. So our n cap is nebula phi divided by how much? Modulus of nebula phi. So our nebula phi is, if we take 2 common, x I cap plus y j cap plus z k cap divided by how much? Magnitude of this. So magnitude of this means what? A square means twice x whole square plus twice y whole square plus twice z whole square. So what you will get? You will get 4 into x square plus y square plus z square. Okay, 4 into root over sign will be there, root over a square plus b square plus c square. Okay, so this is the value that you will get. Now what is x square plus y square plus z square? It is given in the question. How much it is? 1. So in place of x square plus y square plus z square, you can write 1. So you will get 2 x I cap y j cap plus z k cap divided by this 4. It will come out from the root, it will become 2, and then x square plus y square plus z square is how much? 1. So this cancel out. So you get the unit normal vector, which is x I cap plus y j cap and then what? Z k cap. What is f bar here? F bar, it is given in the question. Yz I cap plus zx j cap and xy k cap. So yz I cap plus zx j cap plus xy k cap. Then what to find? We have to find f bar dot n cap. So this is our f bar, and just now we find what? N cap. So dot product. So dot product is xyz. Again you will get xyz. Again you will get what? xyz. So it will become 3xyz. Okay, 3xyz. So this is the value of f bar dot n cap. Next step is what? We have to take the projection of S. So let R be the projection of S on which plane? On xy plane. Okay, on the xy plane. So therefore ds equals to how much? It is dx dy divided by modulus n cap dot k cap. So see, this is our n cap, right? This is our n cap. So with this n cap, if you take the dot product of k cap, so k cap dot k cap equals to how much? 1. Other two will become 0. So how much you will get? You will get z. So this is dx dy divided by how much? Z. Now let us do the integration. Double integration over s f bar dot n cap ds. So this is equals to double integration over r, because the r is the projection of s. In place of f bar dot n cap we can write 3xyz, and then in place of ds we will write dx dy divided by z. So like the previous problem, we no need to put the value of z, because here z is cancel out. So now our integration is strictly what? X and y. So now the important part, we have to put the limit of what? X and y. So what is the surface? Surface is x square plus y square plus z square equals to how much? 1. So what I said in the last problem, when we find the value of y, we have to put z equals to 0. So if we put z equal to 0, what do we have? X square plus y square equals to how much? 1. So from here, y equals to root over 1 minus x square. So what is the limit? The limit of y is 0 to y0, again first quadrant, from 1 minus x square. Then what we will do? Now we will find the limit of x. So when we find the limit of x, we have to put y equals to 0. So if we put y equals to 0, how much we will get? X square equals to 1. If x square equals to 1, the value of x is how much? Plus minus 1. But since we are in positive first octane, so x cannot be negative. So x equals to how much? 1. So limit of x is 0 to 1. Okay. Now simply you have to integrate it. Okay. So this is equals to 3 into 0 to 1. What is on the right hand side is x square plus y square equals to 1. Okay. Now x will see, the limit of y is dependent on x. So first we have to integrate with respect to y. So it's y square by 2 between the limit 0 to 1 minus x square, dx will be left out. So 3 by 2 will be outside, x equal to 0 to 1, x into, now if you put the limit in place of y, so it will become root over 1 minus x square whole square. So root will vanish, 1 minus x square dx. So 3 by 2 is x integration x minus x cube dx. Limit is 0 to 1. So 3 by 2 integration of x is how much? X square by 2 minus this is x to the power 4 by 4 between the limit 0 to 1. Now when you put the limit 3 by 2, when you put the limit, it will be half minus 1 by 4, right? So 3 by 2 into 1 by 4. So 3 by 8 is the answer. Okay. So you see, problems are very, very simple. So I'll request you to do some more problems from any book. Okay. Or in net also, you'll get internet also, you'll find several PDFs. So from there, you at least do 3-4 problems, so that surface integral will be very easy to all of you. So I hope you understand and all the problems of surface integral. So if you like my videos, kindly subscribe and share. Thank you for watching.